Welcome to a new test and teardown video. This time it's a Philips Digital Multimeter PM2422A. In fact, this model is the A5 model. There are many different versions of this, and they look actually very different, and they all carry the same 2422. And then you'll see them from A2, 3, 4, 5, and so on. So this is the A5 model. And yeah, as you already noticed, this knob is not the original. They are actually a lot smaller with two long little plastic things that stick out. And they are a little bit confusing because one sticks up and the other one sticks down, and it's almost impossible to see what is what, if it is this or if it's that. So I think this is actually a better knob compared to the original. Yeah, they call this a multimeter, and what it can do is measure volts and ohms and current, and it is a NIXIE tube meter. We got 3 ZM1000 and a 1 and a minus. The 1 and the minus, that's just neon bulbs. I was told this should work, so I could actually just plug it in and let's see what happens. Hopefully it will work. Let's go to DC. Let's go to 20 volts. And let's see what happens. Let me input some volts. Let's try and power this up. Mains is applied and yay! Wow, man, we got, oh, they're dim. That is sad to see, but of course they are also very, very old. But let's try and see what happens if I, okay, yeah, great. And this should be 9. Ooh, not perfect, right? So that was 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, that is funny. So there's some all range features. So this is 1. Okay, fine, let's go 1.1. Okay. So if I turn it up like this, ooh, there's definitely something that is working. So this is 1.9. So far so good. So that is very, very good. But there's a digit missing down here as well, right? Why is that one not lit up? Okay, that is because I am in 2-volt mode. I am a moped. Listen to that. It's because this knob is not the original one. So if I go here, this is 20 volts range. My God. Okay, great. So this is 2 volts. Okay, let's go. Okay, so this is the 20 volts range. So that means it can show 19. Oops. Hello? Why are you so lame? Okay, good. It is a little bit off scale, so this is actually 17. It is now showing 19. But what I am expecting was one more digit, because there should be 3 digit and this number 1. So yeah, I need to open it, and also there's definitely some calibration stuff. So this was the 20. Yeah, and here is 17. Okay, so it shows a little bit too much actually, right? Or is it just crap in the? All right, I need to play a little bit more with this, and then I will get back. Let's look a little bit on the back. Yeah. One of the cable holders here was completely cracked away, and the other one is more or less crap as well. And this is what happens when people drop these or transport it. Here it is okay in this end. I think it's fairly easy to 3D design this and 3D print a new one, if this is what we want to do. Or I could just live with not having any. So I guess this is how we open and have a look. And yeah, this is what I said. This is the A5 model. And also, I guess the fuse is inside, right? So now we are inside, and I must say this one is dirty, and it smells like ashtray. Oh my gosh, like a lot. Oy, oy, oy. So this was definitely a smoker unit. Ooh, that is not so nice, but I can clean this. Wow, look at that big heavy duty fuse. And like I said, one of the tubes is not lighting up. By the way, when we're playing around with NIXIEs, don't stick your fingers in stuff here, because they run at a higher voltage, plenty to give you a little shock on your fingers. And they're called ZM1005. That is a little surprise. I was expecting 1000. But anyway, yeah, one is missing. And as far as I can tell, this is a mixed display. We got those transistors here, and it looks like everything else is connected in parallel, right? So you select one of the tubes with the selector transistor. So this is probably what is not happening, I hope, because the cathode drivers is most likely this kind of stuff. I'm going to see if I can find some schematics, and let's see if we can get smarter. So this is the minus digit, and this is the extra 1, and that one is working. So this is a cheap way to make like a 1 and 3 decimals, right? And yeah, I see a lot of funny things in here. By the way, that one, what exactly is the idea with that one? But it is really dirty. I'm going to clean this up, both for the smell, but also because this is not so nice. Whoa, this unit is really old. Let's look at the back side of the PCB. Some really beautiful PCB layout. And this is the mains fuse. Also, I really like the mains switch to be located all the way back and far away from the sensitive input parts. So it can be just all located here at the transformator part. So that is good. I see a little bit of a measurement test point added there. And this is the back side of all the NIXIE tubes. It is really dirty in here. Let's have a look. Oops, at the NIXIEs again. So there was actually one little thing I wanted to show. See the 74141 right there. That is a NIXIE driver, a high voltage driver for NIXIE tubes. And because you only see one of them, you definitely know this is a mixed system. And because these two are working, you know that one is definitely working. And of course it's also connected to the other tube. And what we see here is actually the anode resistor going to each of the anode selectors. So that is what I'm going to try at the first, to see if there's a normal anode pulse, a positive, high positive voltage on each of these. I know this comes, then this comes, and then this one is probably missing. So is it missing? Is it the transistor, or is it the resistor, or is it the tube? So before we start measuring around in the circuit here and waste a lot of time, so here's what I did. They're in a socket, so I just took them all out and swapped them. And this one is the one that's supposed to be defective. And look, they have been, one of them has been like replaced. There's another name on that one. Philips is missing on those two, right? But anyway, this one was the one that's not working, and now it's up there. I just moved them all around and then cleaned them. So let's see. But what I also did when I had this out, I tested it with my neon tester. See? And there's definitely action in it, so that means there's still neon and good stuff in this one. But see, it's not only neon that it takes. Now it's actually working here. So that means this neon tube is defect. The NIXIE tube is defect. And that is something you don't see that often. I would actually expect the multiplexer to be broken, but yeah. That is the problem. So looking through my pile of tubes, of course I find another ZM1000, 1005. Looks a little bit different from 1000. You can see the anode grid looks a little bit different. Actually the tube's in a little bit better condition. But what I see is the dot point, that little thingy down there, goes to that pin, and that is broken. Or somebody cut this off. But I think that is what we need in this instrument. But now I'm gonna try and plug it in and see if it works. We're finally back on track. We got 3 digits that's working. Ah, that was terrible. So I found 2 other. They didn't work, and they actually turn on with my neon bulb tester. So I had to find another board with ZM1000 and desolder one. Damn it, that was difficult. And plug that one in. And what do you know? This damn thing is working finally. Let's turn off the light here. So that means, okay, so all the dot points actually also work. And now I can start the calibration and whatnot. Phew, happy camper. What a fight. I took the entire machine completely to bits and pieces, cleaned everything in both alcohol and acetone and whatnot. And I mean, now it is nice and shiny, so clean and nice. But there's actually one thing that I found. Look at that one. That is broken. So this I need to fix. So that is maybe why the voltage is very much off. And this is how you clean the glass and take it out. You need to take this side panel off. This way you can slide up the display glass and clean it correctly. See, it's locked by this thing as well. Here, then it's locked. See, that is the broken resistor, and thank God for good documentation. It is R608. Easy. So after all this cleaning and lubricating and fixing this and that, also fixed this broken resistor in the reference circuit, and of course now it is measuring very accurately. I didn't even trim anything. I didn't mount this correctly because I think I could score this knob from another Philips that I recently played with that I was not able to restore or repair, so I think I'll just score the knob. So that means this unit is super duper good. So this is 30.1 volt, and this is even before calibration. Happy. I really like the way that it works in ohms. I've been all the way around all the different features here, but in ohms it's doing something like this when it's open. I just found so this is 200 kilo ohm range, so of course I found a 100 kilo ohm resistor, but just to be sure, let's test it. 99.6 kilo ohms, and this meter says about 99 kilo ohms, so that is very close. And again, I did not touch any trimmers at all in this instrument yet. I only repaired this broken resistor and of course cleaned all the switches and stuff. So the last thing is AC volts. I should be in 2 volt full range, and I am now in AC. And look, this is about 1 volt RMS, and I believe this is 1 volt RMS. This is 10 kilohertz, and it even works to like 30-40 kilohertz. Then it goes down, and if I say 100 hertz, and it's still this 1 volt. How about we go all the way down? So this is 50 hertz. What? 10? Really? Okay. 5 hertz. Are you kidding me? Okay, it starts to doing the, but from 10 hertz, still a little bit jumpy. So that is 20, and it is a little bit, but anyway, that is AC volts, 1 volt at 25 hertz. I am very happy about this instrument, and it's beautiful.